Hello everybody. Today we are going to talk about the lifespan of buildings, their longevity, and this concerning the three material groups that I have been talking about last time, which is mineral and metallic and organic. As you can see in this rather unspectacular corner, you have a rather long-lasting building built out of mineral materials. This is a brick wall with a stucco on top, and it's there already for 100 years, and I think it can last another 100 years. Unfortunately, this was renovated and covered with thermal insulation, and this is when, in my opinion, the problems started to occur, because well, this is 3 years old and it looks already much worse than the other side that has been maintained but is in general 100 years old. So as you can see, organic materials are aging rather quickly. This is a piece of wood after a couple of years, and you can see that it starts to gray out, loses its consistency and starts to deteriorate. Behind this is a thermal insulation as well. This is not such a good idea for the aging process. In general, working with thin layers is also aging in a rather particular way. The pyramids are massive constructions with almost no space inside. So here you have 100 meters of mineral material and just a little chamber on the inside, and this is the building, one of the buildings that lasted long in human history. Wooden buildings are much rarer. Normally they burn or deteriorate during a rather short time and then disappear. So you can see that there is rust corrosion forming on this steel grill. The thin metal here is aging more quickly. This can rust another 50 years before it will not be functional anymore, while this here deteriorates much quicker. This can be prevented by special paint here. This is a duplex procedure. I'm walking here on natural stone. This natural stone will last a long time as well, although there is organic growth in the joints here. My theory is that working with massive elements provokes longer lasting aging process, and such elements can last for a longer period in time. So here we have a door out of wood. You can see the traces of its age. The weathering zone for spillage water, which is about 30 centimeters high. The wood grays out in this area here. In certain parts the wood has gotten a lighter color due to sunlight, and there's corrosion as well from these. They must be brass screws, and you can see the corrosion traces. But all of this is very nice and adds to the particular charm of this wooden door here. I'm next to a painted door. You can see that this adding of a layer of paint provokes a rather pronounced aging process in the areas where it has been touched. I'm walking once again on a natural stone floor. These are Solnhofer limestones, and they don't have to be protected, and they last for a rather long time. Hey, so here's another massive material. It's reinforced concrete, and as you can see, it's not so much the concrete that is provoking the aging problem, but the composite character, where the surface surface protection starts to get weaker, and then as it is not protected anymore, the rebar starts to rust, increases its volume, and then pushes off the concrete that is covering it. So actually mixing materials is also bad for longevity. Please take a look around to make your own observations. Here we have, for example, brick aging very well. You can see that it's not so easy to rust protect metal pieces. Here once again, wood, after a couple of years it starts to fade out. At the end there are fibers splitting off. Here another metal piece in a concrete wall. You have a little organic growth on the concrete wall as well. In the long run, this organic growth will be harming the concrete surface. Now, an interesting question is how to treat the building components once they have become obsolete and the building is demolished. Recycling. Well, labor is very expensive, so it is improbable that someone will go to this brick wall and separate each brick from the mortar and recycle it in another building. So what people are doing in these cultures with high salaries is to demolish the building as a whole and then have a process of separation and homogenization of the big pile of junk. So you will try to extract the metal, you will try to extract the minerals, and you will try to extract the organic material and then recycle them in their proper way. There is a European framework directive concerning recycling processes, and this directive is rather just in what it says. It says that avoiding to create waste is the best way to treat it. So if we would reuse this building for another 100 years instead of demolishing it, that's the best way to treat the waste problem. This is my opinion as well. So the first priority is avoiding. Then the second priority would be reusing elements, like for example taking this building, which is now a university building, and living in it. Behind me you can see a provisional fire escape out of a prefabricated system which is used for scaffolding. And in Germany we have changed the building regulations. Fire protection has become more severe. So all of a sudden we needed a fire escape for 2 years. So to make this out of a lightweight material is rather logical, because it lasts for such a short time and can be completely disassembled and reused at another place. If you cannot go for the long run, then try to adapt your construction to the period that the building is used for. These are two parts of the same building. One is fitted with an exterior insulation with stucco on top of it. You can see that it's reinforced with glass fiber mats, and the other side apparent bricks. Not very thick, it's about 11.5 centimeters thick, and this is the air intake for the ventilation layer behind the bricks. So the bricks are held in place by metal anchors and supported by cantilevering supports. So it's not a massive building, but nevertheless this ages much better than the other side. I'm standing in front of different types of facade. Here we have an aluminum siding. In the base zone it's rather a reinforced concrete prefab element. Here we have fiber cement plates, rather freshly mounted. Behind me several brick buildings. Brick has the reputation to be rather long-lasting. We will go a little closer to see how this is achieved. So the building behind me shows that if you take an otherwise long-lasting material and combine it with other constructions, like in this case the reinforced concrete pile behind the siding consisting of the yellow bricks, you might have rust of the rebars in the concrete column, which is then pushing off the siding of the bricks. So something which is rather long-lasting can be put in a context where it's not this long-lasting at all.